Chapter 9.4 Conditions for rectangles, rhombuses, and squares. Condiciones para rectángulos, rombos, y cuadrados. Okay, so in this chapter, we're going to look at conditions that have to exist in order for us to determine whether we have a rectangle, a rhombus, or a square. On this first slide, let's look at two conditions that if they exist, they confirm that we have a rectangle. All right, so we have these two theorems, and it says conditions for rectangles. The first one, if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So if you look right here at this diagram, first of all, we have a parallelogram. How do we know that we have a parallelogram? Because of the arrows on opposite sides. The arrows are telling us that this side is parallel to this side, and the top side is parallel to the bottom side. So we have a parallelogram, and it shows that we have one right angle. All right, so the theorem says that if just one angle of a parallelogram is a right angle, then with that information, we can confirm that this parallelogram is a rectangle. The second condition that if you see it, that means that this is a rectangle, is that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So again, you have a parallelogram. Once you see that the diagonals are congruent, as you see in this case, then that's it. With just that information, we can confirm that the parallelogram is a rectangle. So if a parallelogram has just one right angle, that's it. We can confirm that it's a rectangle. And if it has congruent diagonals, we could also confirm that it's a rectangle. En este capítulo estamos mirando a condiciones que, si existen, podemos determinar que tenemos un rectángulo o un rombo o un cuadrado. Aquí tenemos dos condiciones. El primero dice que si solamente un ángulo de un paralelogramo es un ángulo recto, entonces ese paralelogramo es un rectángulo. ¿Okay? Así que si miran aquí, tenemos un paralelogramo. Lo sabemos que es un paralelogramo por esas flechas que quieren decir paralelo. ¿Okay? Que los lados son paralelos uno al otro. Y en este diagrama solamente están enseñando un ángulo recto. Ángulo A es un ángulo recto. Así que si solamente uno de los ángulos, si sabemos que un ángulo es un ángulo recto, ya con esa información podemos confirmar que este paralelogramo es un rectángulo. Y la segunda condición es que si los diagonales de un paralelogramo son congruentes, entonces ese paralelogramo podemos confirmar que es un rectángulo, que es lo que están enseñando aquí. Tenemos un paralelogramo y los diagonales son congruentes, así que ya con esa información podemos determinar que esto tiene que ser un rectángulo. All right, so here's a proof that we got to look at that's on your homework. It says prove that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Tenemos que comprobar que si los diagonales de un paralelogramo son congruentes, entonces este paralelogramo es un rectángulo. All right, so given that ABCD is a parallelogram and AC is congruent to BD, so they're telling you right here that the diagonals are congruent. Prove that this is a rectangle. Prove that this is a rectangle. All right, so first step says because opposite sides of a parallelogram are congruent. All right, that's included in the definition of a parallelogram. Okay, so because opposite sides of a parallelogram are congruent, AB is congruent to segment CD. And then it says it is given that AC is congruent to BD. Those are the diagonals. And AD is congruent to AD by the reflexive property. Okay, so what they're doing is this. They're looking at these parts of the rectangle. They're looking at this part, which is ADC. Actually, I'm sorry. Let me do the top part first. They're looking at this part, which is ADB, as well as this part, which is ADC. All right, so if you look at those parts, they said, hey, this side is congruent to this side. The diagonals are congruent to each other because that's given. And this side is congruent to this side because of the reflexive property, because it's the same side. So basically, side, 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 side. All right, so they prove that the two triangles are congruent. Triangle ABD is congruent to triangle DCA by the SSS triangle congruence theorem, side, side, side. Okay, and as I've said before, once you prove that two triangles are congruent, you could pick corresponding parts, whatever corresponding parts you need for your proof, and put the reason as CPCTC, corresponding parts of congruent triangles are congruent. So angle BAD, which is this one, whoops, I didn't mean to put that. Let's put that. Angle BAD is congruent to angle CDA because corresponding parts of congruent triangles are congruent. Okay, now it says here, but these angles are supplementary since AB is parallel to DC, because consecutive angles in a parallelogram are supplementary. Therefore, when you add the measure of angle BAD plus the measure of angle CAD, it has to equal 180. But since we already showed that the two triangles are congruent and this angle corresponds to this angle, that means that you could substitute angle BAD for angle CDA, and when you add them both up, they got to equal 180. So that means that basically each one of them has to equal the same amount, which is 90 degrees. And if each one of them is 90 degrees, we saw that if just one angle of a rectangle is 90 degrees, that means that, I'm sorry, if just one angle of a parallelogram is 90 degrees, then that means the whole thing is a rectangle. All right, so you could see the rest, right? So that's how they prove that this parallelogram is a rectangle. Enseñaron por lado, lado, lado que estos dos triángulos que están contenidos dentro de este paralelogramo son congruentes y que este ángulo es congruente a este ángulo. Y como en un paralelogramo los ángulos consecutivos son suplementarios, eso quiere decir que este ángulo más este ángulo la suma te tiene que dar 180, pero si los dos ángulos son congruentes, eso quiere decir que cada uno tiene que medir 90 grados, y si ya vimos que si solamente un ángulo en un paralelogramo mide 90 grados, eso quiere decir que ese paralelogramo es un rectángulo. To determine whether the quadrilateral is necessarily a rectangle and explain your reasoning. All right, so we gotta, with the information they're giving us, we gotta determine, is this a rectangle, yes or no. Con la información que nos están dando, tenemos que determinar si esto es un rectángulo, sí o no. Okay, now question number 4 has an error in it. All right, and I'll tell you what it is and I'll explain why. Okay, la pregunta 4 tiene un error. It says, given that segment EF is congruent to, this should say GH, and it says GF by accident. That's a mistake. All right, so given that segment EF is congruent to segment GH, and segment FG is congruent to segment HE. All right, so before we continue and look at the last part, all right, if opposite sides are congruent, let me write that. If opposite sides of a quadrilateral are congruent. If opposite sides of a quadrilateral are congruent, then we have a parallelogram. All right, if opposite sides of a quadrilateral are congruent, then that confirms that this quadrilateral is a parallelogram. Okay, now the second part right here says that the diagonals are congruent. Segment FH is congruent to segment GE. And if the diagonals of a parallelogram are congruent, then yes, Yes, we do have a rectangle. Yes, we can confirm that we have a rectangle. Okay, the reason I said that we have an error here is because we can only determine that it's a rectangle if the diagonals of a parallelogram are congruent. But nowhere up here does it say that this is a parallelogram. It does not show in the picture that this is a parallelogram. So first thing I got to do is determine, is this a parallelogram? And yes, I could determine that based on the information at the beginning that says that opposite sides are congruent. Because if opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. All right. It may sound a little bit complicated. It's not, but I had to explain all that, okay? Si los lados opuestos de un cuadrilátero son congruentes, entonces tenemos un paralelogramo. Y si los diagonales de un paralelogramo son congruentes, entonces sí tenemos un rectángulo. Así que por eso escribí que sí se puede determinar que esto es un rectángulo. Okay. En la pregunta había un error porque tenía la letra equivocada aquí. Y primero, antes de poder determinar que es un rectángulo, tuve que comprobar que es un paralelogramo. All right, number 5. Given that the measure of angle FEG is 45 degrees and the measure of angle GEH is 50 degrees, can we confirm that this is a rectangle? All right, can we confirm just with that information that this is a rectangle? The answer is no, because in order to have a rectangle, you got to have one of two conditions present. Okay, either the diagonals have to be congruent inside of a parallelogram, or we have to have at least one, we have to have one right angle inside of the parallelogram. Okay, and we don't, with the information they gave us, we do not have one right angle inside of a parallelogram, nor do we have congruent diagonals inside of a parallelogram. So no, with that information I cannot confirm that it's a rectangle. Okay, con esta información no puedo decir que es un rectángulo porque para hacer un rectángulo necesito uno, por lo menos necesito confirmar uno de dos posibles condiciones. Número uno, que los diagonales son congruentes dentro de un paralelogramo, o tener un ángulo recto dentro de un paralelogramo. Y no tengo ninguna de esas dos condiciones en el número 5. Okay, now we're going to look at the conditions that have to exist in order to determine that we have a rhombus. In case you forgot, a rhombus, I put it over here. A rhombus is a quadrilateral with 4 congruent sides. Ahora vamos a mirar las condiciones que tienen que existir para determinar si tenemos un rombo. Si se le olvidó, un rombo es un cuadrilátero con 4 lados congruentes. Okay, so here are the conditions for a rhombus. The first one, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So if you look at the picture, we have a parallelogram because it shows that opposite sides are parallel, but it only shows that one pair of consecutive sides are congruent. So just with that, if just one pair of consecutive sides of a parallelogram are congruent, then that's it. It's a rhombus. Okay. Number 2, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If the diagonals are perpendicular, remember perpendicular means they create a 90-degree angle, then just with that we could determine that it's a rhombus. And the third condition that we could look for is if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So here's my parallelogram, and I got this diagonal that's bisecting a pair of opposite angles. Bisecting means going through the middle. So once you see that, we can also determine that it is a rhombus. So again, Condition 1, if a pair of consecutive sides are congruent in a parallelogram. Condition 2, if the diagonals are perpendicular in a parallelogram. And condition 3, if one of the diagonals bisects a pair of opposite angles in a parallelogram, which we'll look at some problems in a second. Okay, así que hay tres condiciones que si lo vemos cualquiera de ellos, podemos determinar que tenemos un rombo. El primero es si un par de lados consecutivos son congruentes, entonces podemos decir que es un rombo. Ok, así que aquí tenemos un paralelogramo y solamente un par de lados consecutivos son congruentes, pero con ver eso ya se puede decir que es un rombo. El número 2, si los diagonales de un paralelogramo son perpendicular, entonces con eso podemos decir que tiene que ser un rombo. Perpendicular quiere decir que forma un ángulo recto de 90 grados. ¿Okay? Y la última condición, si un diagonal está bisectando un par de ángulos opuestos, con simplemente eso podemos decir que es un rombo. All right, and here's a proof that we got to look at. They want us to, if given that ABCD is a parallelogram and angles BCA is congruent to angle DCA, BCA is congruent to angle DCA, and BAC is congruent to angle DAC, prove that ABCD is a rhombus. All right, so it's a parallelogram, okay, and this angle is congruent to this one, and this one is congruent to this one. All right, they could be equal to each other as well, but I'm just showing that the diagonal is bisecting a pair of opposite angles. Actually, hold on, let me fix that real quick. They gotta measure the same if it's a parallelogram. Okay, so first they put the given information on the top, and that angle segment AC is congruent to segment AC because of the reflexive property of congruence. Okay, so if you look at the picture, you got angle, side, angle. For these two triangles, angle, side, angle, angle, side, angle. The two triangles are congruent because of the angle, side, angle, triangle congruence theorem. Okay, if the two triangles are congruent, then we could pick whatever corresponding parts we need and put the reason as CP, CTC. Okay, so they put that segment BC is congruent to segment DC. Those are consecutive sides. And AB is congruent to AD. Those are consecutive sides as well. Okay, so once you prove that consecutive sides of a parallelogram are congruent, that's it. You could say that it's a rhombus. All right, so if this is on your homework, you could use this to guide you on the proof, okay? Usaron primero ángulo, lado, ángulo para decir que estos dos triángulos son congruentes. A la vez que determinaron que los dos triángulos son congruentes, pueden poner la parte correspondiente que necesitan, que es lo que hicieron aquí, y para la razón poner que las partes correspondientes de triángulos congruentes son congruentes. Así que el lado BC es congruente al lado CD y el lado AB congruente al lado AD. Esos son lados consecutivos y ya vimos que si lados consecutivos en un rombo son congruentes, déjame decir eso mejor, si lados consecutivos son congruentes en un paralelogramo, podemos decir que ese paralelogramo es un rombo. All right, moving on. All right, so prove that if one pair of consecutive sides of a parallelogram are congruent, then it is a rhombus. Tenemos que comprobar que si un par de lados consecutivos de un paralelogramo son congruentes, que tenemos un rombo. All right, so it says here JK is congruent to KL. All right, so it is given that JK is congruent to KL because opposite sides of a parallelogram are congruent. So once they told you that this is a parallelogram, it's okay to say, hey, opposite sides are congruent. So since opposite sides are congruent, KL is congruent to MJ. So KL, which is this one, is congruent to MJ. And JK, which is this one, is congruent to LM. By substituting the sides JK for KL and vice versa, they could show that that consecutive sides are congruent. So therefore, we could say that this is a rhombus. Okay. Así que nos dicen que esto es un paralelogramo y que el lado JK es congruente al lado KL. Esos son lados consecutivos. A la vez que te dicen que esto es un paralelogramo, ya podemos decir definitivamente que por la definición de un paralelogramo, los lados opuestos tienen que ser congruentes. Así que el lado JK es congruente al lado LM y el lado KL es congruente al lado JM. Y a la vez que enseñan que los lados consecutivos son congruentes en un paralelogramo, ya podemos decir que es un rombo. ¿Ok? Pero explicaron aquí que si sustituyen los lados JK para KL o KL para JK, pueden enseñar que el lado JK es congruente al lado MJ y KL congruente al lado LM. Así que todos los lados son congruentes. Así que el cuadrilátero JK-LM tiene que ser un rombo. Okay, here we got to determine, you're not going to have to do all this work. We just got to determine if this conclusion is valid. All right? Tenemos que determinar si esta conclusión es válido o no. In other words, can we say with this given information that ABCD is a square? Yes or no? Okay, con la información que nos están dando, podemos determinar que ABCD es un cuadrado, sí o no. Eso es la pregunta. All right, so to prove that a given quadrilateral is a square, it is sufficient to show that the figure is both a rectangle and a rhombus. All right, para comprobar que un cuadrilátero es un cuadrado, lo pueden hacer enseñando que la figura es los dos, un rectángulo y un rombo. All right, so step 1, determine if ABCD is a parallelogram. All right, so since opposite sides are congruent, okay, since opposite sides are congruent, we know that ABCD is a parallelogram. Hold on. Since opposite sides are congruent, they're probably all going to be equal, but for now I just put it like that because I don't know that yet, okay? Como aquí dice que los lados opuestos son congruentes, eso no dice que sí tiene que ser un paralelogramo. Eso es el primer paso, determinar si es un paralelogramo. Step 2, determine if ABCD is a rectangle. Since it says right here that AD is perpendicular to DC, and AC is perpendicular to BD. All right, the first part, AD is perpendicular to DC. That means this has to be a right angle. And the second part is saying that the diagonals are perpendicular because AC and BD are diagonals. So since AD is perpendicular to DC, by definition of perpendicular lines, angle ADC is a right angle. A parallelogram with one right angle is a rectangle. So once you prove that it has one right angle, it's a rectangle. So ABCD is a rectangle. Actually, I didn't need this part for that part. Okay? So, para paso 2, para determinar si es un rectángulo, dice que el segmento AD es perpendicular al segmento DC. Eso quiere decir que este ángulo es un ángulo recto. Y a la vez que enseñan que un paralelogramo tiene un ángulo recto, ya tiene que ser un rectángulo. Step 3, determine if ABCD is a rhombus. All right, since AC is perpendicular to BD, that's this part right here. In other words, since the diagonals are perpendicular, A parallelogram with perpendicular diagonals is a rhombus. ¿Ok? Un paralelogramo con diagonales que son perpendicular es un rombo. Step 4. Determine if ABCD is a square. Since ABCD is a rectangle as well as a rhombus, that means it has 4 right angles and 4 congruent sides. And that's what you need to be a square. To be a square, you got to have 4 right angles and 4 congruent. You got to be a quadrilateral. Let me say that better. A parallelogram with 4 right angles and 4 congruent sides. So that's how you determine that it's a square. First, they determine that it's a parallelogram. Then, is it a rectangle? Then, is it a rhombus? If all of these are yes, then that means it's a square. Okay? Como el paralelogramo ABCD es un rectángulo y un rombo, ya podemos decir que es un cuadrado, porque la definición de un cuadrado es que tiene que tener 4 ángulos rectos y 4 lados congruentes. Así que el primer paso era determinar si es un paralelogramo, el segundo determinar si es un rectángulo y el tercero determinar si es un rombo. Si todo eso, si esos tres son sí, entonces ya podemos decir que es un cuadrado, porque eso es lo que es un cuadrado, un rombo, un rectángulo y un paralelogramo. So given that AB is congruent to BC, can we conclude that ABCD is a rhombus? Okay, no. Okay, it is, okay, hold on. It is true that if 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. However, we don't know that this is a parallelogram. All right, so look at this, because you're going to have stuff like this on your homework. Okay, we said that in order to be a rhombus, it has to be a parallelogram. Let me draw it here so you can see what I mean. In order to be a rhombus, you'd have to have a parallelogram all right, with two with at least one pair of consecutive sides that are congruent, like this side congruent to this side. We have the congruent consecutive sides here, but we don't show that it's a parallelogram. We don't know for sure that it's a parallelogram. So that's why the given information is not sufficient to determine that the figure is a parallelogram, okay? No podemos determinar que es un rombo porque para hacer un rombo tiene que ser un paralelogramo con lados consecutivos que son congruentes. En este diagrama sí tenemos los lados consecutivos que son congruentes, pero no sabemos definitivamente si esto es un paralelogramo o no, así que no podemos determinar. All right, moving on. All right, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. Tenemos que determinar si esta conclusión es válido y si no, tenemos que explicar cuál es la información más que necesitamos. Okay? So, given that ABCD is a right angle, I'm sorry, I read that wrong. Given that angle ABC is a right angle, can we conclude that ABCD is a rectangle, yes or no? Think about that while I repeat it in Spanish. Again, if angle ABC is a right angle, can we conclude that this is a rectangle, yes or no? Okay, si ángulo ABC es un ángulo recto, la pregunta es que si podemos concluir que ABCD es un rectángulo. All right, the answer that you should be thinking of is no, because in order to be a rectangle, it's got to be a parallelogram, and we do not know if it's a parallelogram. It doesn't say that this is a parallelogram. And without that information, we can't determine if it's a rectangle. If we knew for sure that it was a parallelogram, like I didn't draw it exactly right, but whatever, you get the idea. Like let's say it had this and this, okay, and then the right angle, then yes, we could say that yes, that is a rectangle. But without knowing for sure that it's a parallelogram, we can't say that it's a rectangle, okay? La respuesta es no. I didn't mean to put that comma there. Okay, la respuesta es no, porque para ser un rectángulo tiene que ser un paralelogramo que tiene por lo menos, que sabemos que tiene un ángulo recto, por lo menos. Si tiene esta figura un ángulo recto, pero no sabemos si es un paralelogramo. No nos dice en ningún lugar, ni en el diagrama, ni aquí en la pregunta, no nos dice que es un paralelogramo, así que no podemos decir definitivamente que es un rectángulo. All right, that's what it says here. All right. Okay, questions 9 and 10. We also have to determine if the conclusion is valid, and if not, we have to say what additional information is needed to make it valid. All right, so for question 9, it says given that EG and FH bisect each other, and EG is perpendicular to FH, can we conclude that EFGH is a rhombus? Yes or no? Number 9 could be tricky. All right, so I would listen to this explanation. Okay, in the previous chapter, we went over that if you have a quadrilateral like we do here, and the diagonals bisect each other, then that means that this is a parallelogram. That's really important and easy to miss. Okay, so again, in chapter 9.2 and also 9.1, but in 9.2 we saw that if the diagonals of a quadrilateral bisect each other, okay, if they bisect each other, that means that this quadrilateral has to be a parallelogram, okay? And that's what it's telling us here, that yes, this is a parallelogram. That brings us to our second part. The diagonals are perpendicular. And we just learned a few slides ago that if the diagonals of a parallelogram are perpendicular, then that means that you have a rhombus. So the answer on this one is yes. The conclusion is valid. This is a very easy one to get wrong. So let me just say it one more time. In chapter 9.2, we learned that if you have a quadrilateral and the diagonals bisect each other, then that means that the quadrilateral is a parallelogram. Okay, and now in this chapter, we learned that if you have a parallelogram and the diagonals are perpendicular, then it has to be a rhombus. So that's why in this one, the answer is yes, the conclusion is valid. And then let's look at actually, let me explain it in Spanish before I go on to number 10. En el capítulo 9.2 aprendimos que si en un cuadrilátero, como lo que tenemos aquí, okay, si los diagonales bisectan uno al otro, eso quiere decir que ese paralelogramo, déjame empezar otra vez. Si en un cuadrilátero los diagonales bisectan uno al otro, eso quiere decir que ese cuadrilátero tiene que ser un paralelogramo. Okay, así que con eso sé que esto es un paralelogramo. Y en este capítulo ya vimos que si los diagonales de un paralelogramo son perpendicular, que es lo que dice aquí, eso quiere decir que ese paralelogramo es un rombo. Así que en este caso sí, la conclusión es válido. Okay, number 10. Segment FH bisects angle EFG and angle EHG, all right? So it's bisecting these angles. Can we conclude that it's a rhombus? Okay, in this one, the answer is no, because that would make it a rhombus if it were a parallelogram, and we don't know for sure, sorry that I keep putting that comma, we don't know for sure that this is a parallelogram. In number 9, the part at the beginning allowed us to determine that yes, it's a parallelogram. But in number 10, we don't know that it's a parallelogram. So based on this information alone, we cannot say that it's a rhombus. If it would have said that it's a parallelogram, then yes, according to what we learned today, if a diagonal of a parallelogram bisects a pair of opposite angles, then yes, we would say that yes, it's a rhombus. But because we don't know it's a parallelogram, we cannot say that, okay? En el número 10, no podemos concluir que esto es un rombo. Y la razón es que sí aprendimos hoy que si un segmento, si un diagonal bisecta un par de ángulos opuestos, eso quiere decir que es un rombo, pero tiene que ser un diagonal de un paralelogramo. Y con la información que nos dieron en el número 10 no podemos determinar que esto es un paralelogramo, así que no podemos decir que es un rombo. All right, finally, a question with some numbers and some math. It says, find the value of x that makes each parallelogram the given type, all right? Okay, so what does x have to be for this to be a square, in other words? Okay, so in order to be a square, this has to be a rhombus, and if it's a rhombus, that means that the diagonals are perpendicular. I'm using that information because the only information they gave me has to do with the angles formed by the diagonals. All right, so that has to be, common sense should lead you to think that, well, it must be something to do with that. These angles must be 90 degrees, because what else are you going to do with what they gave you? All right, so remember, a square is a rhombus and also a rectangle. And one of the conditions to be a rhombus is that the diagonals got to be perpendicular. All right, so to solve for the value of x, I would do 13x plus 5.5 has to equal 90. All right, so now I subtract 5.5 from both sides. So I'm going to have 13x equals 84.5. So x equals 84.5 divided by 13. Let me just use a calculator for that real quick here, just 1 second. $84.5 divided by 13. So x equals 6.5. Tenemos que encontrar el valor de x que hace este paralelogramo un cuadrado. Un cuadrado también es un rombo y un rectángulo. Y aprendimos hoy que en un rombo los diagonales son perpendiculares. Aunque no se recuerden de eso, si miran el problema, la única información que te están dando con los números te está diciendo que esto tiene algo que ver con el ángulo. Esto es la medida del ángulo aquí. Y lo único que hemos aprendido de esos ángulos que hacen los diagonales es que son perpendicular en un rombo. Así que tiene que ver algo con eso. Así que la ecuación sería que 13x más 5.5 tiene que ser igual a 90. Y eso nos deja resolver para x y encontrar que x es 6.5. All right, number 12. Okay, in a rhombus, consecutive sides are congruent. Well, all the sides are congruent in a rhombus, okay? So that allows us to make 14 minus x, to make this side equal to this side in order to solve for x. En un rombo, todos los lados son congruentes. Así que puedo poner que este lado es igual a este lado para resolver para x. All right, so if I move the minus x to the right by adding, I'll have 3x equals, and I'll move 5 to the left by subtracting. So 3x equals 9. So x equals 9 divided by 3. So that means that x equals 3. All right, moving on to the next one. We're almost done. All right, this is the last. All right, guys, you're going to have questions on your homework like these where you got to determine which quadrilaterals are parallelograms, rhombuses, rectangles, squares, etc. And you got to list all the names that apply. So some of these have more than one correct answer. Okay, and I'm going to show you what I did here to help you guys answer these questions because it's hard to remember all these different conditions. Okay, so on this slide, all right, on the top, I have the conditions for parallelograms. Here I got the conditions for rectangles. And here I have the conditions for rhombuses. And if it's all three of these, a parallelogram, a rectangle, and a rhombus, that means it's also a square. All right, so as I look at each individual question, I'll just see, first I'll check, is it a parallelogram? Then is it a rectangle? Then is it a rhombus? And last, if it's a square. All right, and you could use this as well while you're doing the homework if you need it. because again, it's hard to remember all the conditions, and it gets confusing. Even I get confused, okay? Let me just say all that in Spanish real quick. En la tarea van a tener preguntas como esta, donde tienen que determinar con la información que le están dando si esto es un paralelogramo, rombo, rectángulo, cuadrado, y algunos tienen más que una respuesta y tienen que poner todas las respuestas correctas. Ok, así que para ayudarlo a hacer este problema, tengo aquí todas las condiciones, aquí arriba todas las condiciones para hacer paralelogramo, después para hacer rectángulo aquí, y aquí las condiciones para hacer un rombo. Y si una figura es un paralelogramo, rectángulo y rombo, eso quiere decir que también es un cuadrado. Ok, un momento. Ok, así que pueden usar esta información cuando están haciendo los problemas para determinar qué tipo de figura tienen. All right, so look at our first one. Look at number 13, all right? And since there's so many conditions, I would recommend like pay attention to how I'm going to approach the problem. All right, so first of all, let's go over the given information. It says xy is congruent to zw. Xy is congruent to zw. XY is parallel to ZW. They're parallel. WY is congruent to XZ. So WY, this entire diagonal is congruent to XZ. And WY and XZ are perpendicular. All right. Okay, so first let's check if it's a parallelogram. Okay. Primero voy a chequear si es un paralelogramo. All right, so the conditions for a parallelogram are if both pairs of opposite sides are congruent. That's not the case. At least we don't know. Both pairs? All right. Right here it says one of the possible conditions are if one pair of opposite sides of a quadrilateral are parallel and congruent. And yes, we do have that. If just one pair of opposite sides are both if one pair of opposite sides of a quadrilateral are both parallel and congruent, then that means it's a parallelogram. And we have that because it says right here that XY is congruent to ZW and it's also parallel to ZW. So it's a parallelogram. We got to check the other ones as well. We're not done. Okay, una de las condiciones para hacer un paralelogramo es si un par de lados opuestos son paralelos y congruentes, entonces es un paralelogramo. Okay, así que ya sabemos que es un paralelogramo. Ahora voy a chequear si es un rectángulo. All right, now let's check if it's a rectangle. Okay, to be a rectangle, you got to have one of these two. If one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. We don't have that here. Okay, si un ángulo de un paralelogramo es un ángulo recto, es un rectángulo, pero no tengo esa información, así que no puedo usar esa condición. How about this one? If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. We have that. That is true. Okay, si los diagonales de un paralelogramo son congruentes, entonces es un rectángulo. Y sí tenemos eso. It says right here that WY is congruent to XZ. So yes, the diagonals are congruent. So we have a rectangle. Okay, now let's check if it's a rhombus. And I'm pretty sure for the rhombus, we're going to use this condition that says that the diagonals are perpendicular. Okay, aquí dice que los diagonales son perpendicular y voy a usar eso para determinar que también es un rombo. If you look right here, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, aquí dice que si los diagonales de un paralelogramo son perpendicular, entonces es un rombo. So we have a rhombus. And if it's all three of these, that means it's also a square. Because a square is a rhombus, a rectangle, and a parallelogram. Okay, si Si una figura es un rombo y un rectángulo, eso quiere decir que también es un cuadrado, porque un cuadrado es todo de estas cosas. All right, so that concludes. I'm done with number 13. Let's look at number 14. All right, so in number 14, given that segment XY is congruent to ZW, XY is congruent to ZW, and XW is congruent to ZY, and WY is congruent to ZX. All right, so the diagonals are congruent. All right, so, okay, first let's check, is it a parallelogram, okay? Primero voy a chequear si es un paralelogramo. And for a parallelogram, it says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram, and we do have that, okay? Both pairs of opposite sides, these sides are congruent and these sides are congruent. So therefore, yes, it's a parallelogram. Para hacer un paralelogramo, si los dos pares de lados opuestos son congruentes, entonces en un cuadrilátero, entonces sí es un paralelogramo. Y sí tenemos esa condición. All right, now over here, it says that the diagonals are congruent. The diagonals are congruent. So let's check if it's a rectangle. And right here it says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Si los diagonales de un paralelogramo son congruentes, entonces es un rectángulo. So yes, it's a rectangle. Okay, now let's check if it's a rhombus. Vamos a chequear si es un rombo. Okay, to be a rhombus, either one pair of consecutive sides of a parallelogram are congruent. Hold on, I'm sorry, let me read that again. One pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Okay, no, because consecutive sides are not congruent. Like this side is congruent to this one, but not congruent to the one next to it. Sorry, I had to read that twice for some reason. All right, so that condition does not apply. Okay, esta condición no existe en ese problema, porque tiene que ser un par de lados consecutivos congruente, y eso no existe. All right, the second condition, if the diagonals are perpendicular, no, those diagonals are not perpendicular. Los diagonales no son perpendicular. And the third condition, if one diagonal of a parallelogram bisects a pair of opposite angles. Si un diagonal bisecta un par de ángulos opuestos, tampoco tenemos eso. So it's not a rhombus. And if it's not a rhombus, that means it's also not a square, so I'm done with 14. No es un rombo, y si no es un rombo, eso quiere decir que tampoco es un cuadrado. Así que ya, esas son las dos respuestas para el 14. All right, number 15. All right, given that angle WXY is congruent to angle YZW, and XYZ is congruent to ZYX. All right, so first of all, you know what? Just to not do everything at once, let's just look at that. All right, with that condition, that means we have a parallelogram. All right, because if you look over here, if both pairs of excuse me, if both pairs of opposite angles of a quadrilateral are congruent, then you have a parallelogram, and that's what we have. Si los dos pares de ángulos opuestos de un cuadrilátero son congruentes, entonces tenemos un paralelogramo. Así que esto es un paralelogramo. Okay, now after that, it says that angle XWY is congruent to angle YWZ, and XYW is congruent to angle ZYW. In other words, let me use a different color. They're saying that this angle is congruent to this angle, and this angle is congruent to this angle. So that means they're talking about this condition right here. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Si un diagonal de un paralelogramo bisecta un par de ángulos opuestos, entonces ese paralelogramo es un rombo. So it's a rhombus. Okay, however, to be a rectangle, it's not a rectangle. Let's look at why. All right, to be a rectangle, you got to have at least one right angle or the diagonals got to be congruent. And we do not have either of those in that question. Para hacer un rectángulo tenemos que tener o un ángulo recto o los diagonales tienen que ser congruentes y no tenemos ninguno de los dos en este problema, así que estas son mis dos respuestas. These are the only two answers for number 15, parallelogram and rhombus. All right, last one. Given that the measure of angle WXY equals 130, WXY is 130 degrees. Okay, angle XWZ is 50 degrees. And the measure of angle WZY is 130 degrees. Okay, first of all, remember that when you add up all the interior angles of a quadrilateral, they always got to add up to 360. Okay, I already know the answer, so I know that this is going to be 50 because that'll add up to 360, all right? Recuerden que la suma de los ángulos interiores de un cuadrilátero siempre te tiene que dar 360. Eso quiere decir que este ángulo tiene que ser 50 para que la suma te dé 360. Okay, so first of all, let's check, is it a parallelogram? Primero que nada, ¿es un paralelogramo, sí o no? So right here, back to this one. If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So yes, it's a parallelogram because both pairs of opposite angles are congruent. Si los dos pares de ángulos opuestos son congruentes, entonces sí es un paralelogramo. Parallelogram. All right. Now, is it a rectangle? To be a rectangle, I need to have at least one right angle, which I don't. Or the diagonals got to be congruent, and they're not. So it's not a rectangle. Okay, no es un rectángulo porque no tiene un ángulo recto ni tiene los diagonales congruentes. Okay, and to be a rhombus, the conditions to be a rhombus are either one pair of consecutive sides that are congruent, or perpendicular diagonals, or a diagonal that bisects a pair of opposite angles, and none of those conditions are present. So therefore, that question is just a parallelogram, nothing else. It's not a rectangle and it's not a rhombus, okay? Para hacer un rombo tenemos que tener o un par de lados consecutivos congruente, que no lo tenemos, o los diagonales perpendicular, que no lo tenemos, o un diagonal que bisecta ángulos opuestos, un par de ángulos opuestos y tampoco lo tenemos. Así que el número 16 solamente es un paralelogramo. All right, guys, that concludes this lesson. The homework is in the student portal. It's due by 6 a.m. the next day that you have my class. All right. Remember that you could use this slide to answer the questions where you got to determine if it's a parallelogram, rectangle, rhombus, or square. I would highly recommend that you use this slide, which will make it a lot easier to answer the question. Just find it in the video. And remember, if it's all three of these, that means it's also a square. Okay. Recuerden que la tarea está en el portal de estudiantes, lo tienen que entregar antes de las 6 de la mañana el próximo día que tienen mi clase, y recuerden que pueden usar el video, esta parte de aquí, para hacer las preguntas donde tienen que determinar si es un paralelogramo, rectángulo, rombo o cuadrado. Y recuerden que si es los tres, eso quiere decir que también es un cuadrado. All right, guys. That's it for today. Hope you guys have a great day, and I'll see you guys next class.